Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, we are going to discuss about time response analysis in control systems. So what is time response? If the output of the control system for an input varies with respect to time, then the system is called as a time response of the control systems. The time response consists of two parts. It is based on transient response as well as the steady state response. If it is having transient and steady state response, then only the system is said to be a time response analysis of the control systems, and it can be calculated and it is denoted by time response as transient response and steady state response by transient response CTR of t, and as well as the steady state response is notified by CSS of t. So both we are having in this graph. So based on the values of the corresponding time, we can able to calculate with respect to the control signals. It is based on input and output. So input is a control system of the corresponding signals, and output is based on the time, certain time to reach the steady state, because it is depend on steady state response. So based on the characteristic equation, the output of the corresponding signals has been changed. It can be followed by limit value. If it is having an infinitive, then automatically the time response of the corresponding signal is 0. An example. So let us find the transient and steady state errors of the time response of the control system is given by C of t equal to 10 plus 5 into e power minus t. So here the second term 5 into e power minus t will be 0, and t denotes infinity because it is having a lot of values, so that the t tends to infinity. So this is the transient term. First term is 10. It remains even as a t approaches as infinity. So this is a steady state term. So based on the transient and steady state term, we can able to find out the corresponding values. Next one is the sum of the examples have been applied for this standard signals. First one is unit impulse signals. Especially for unit impulse signals, the time distance is having del of t equal to 0. After applying the delta of t equal to 0, then automatically then it will reach the value as 0 based on the input signals. And next one is unit step signals. So here the unit step means the step value almost be a 1, because if you are giving an input signal as time signal, then automatically the unit step signal has having the default value as 1. So it reach only 1. After maximum value of 1, it may not be passes to the signals. And next one is RAM signals. The RAM also based on the time signals. So R of t equal to a into t greater than or equal to 0. It may not be reach a maximum value of t. It may be a less than 0 or maximize b by 1. And next one is parabolic signals. So this is a term which is very useful in control system for applying a maximum number of signals, because the transient response and characteristic equations are having more number of powers or roots. So based on the roots only, we can able to check the signal parameters conditions. So by using this unit parabolic signals, we can able to identify the time response of the systems by the following equations. For example, p of t equal to t square by 2. We can expect from the equation is t greater than or equal to 0. So the 0 t less than 0. So then automatically the value will be t squared by 2 into u of t, time response of unit step signals. The instantaneous value of various input signals can be applied to this parabolic signals, and the root caused by the signal is at square by 2, because for Laplace transformation of the corresponding parabolic signals has been achieved by at square by 2, because we can apply the equations as the second order systems, so that it will be very useful to find the corresponding time signals. So assessments, how the test signals varies with the parabolic signals. So even though a lot of signals are present for control systems, so is the system which is very useful to forward the more number of time signals. So when a signal gives the constant accelerations, a distinction of actual input signal, such a signal is known as a parabolic signals or parabolic functions. It is also known as unit acceleration signals. The unit parabolic signal starts at t equal to 0. A parabolic signal is the one. The standard test signal has been forwarded by based on the magnitude, it varies with the time. It is also represented by p of t. Mathematically, it can be represented by t square by t square by 2. With respect to t greater than 0, it may be a positive value, and it can be 0 if it is having negative value. So this is the one of the way which is going to calculate the control system for parabolic signals. Thank you.